Okay, so we talked about sampling distributions for the difference in sample proportions. Now let's talk about confidence intervals. Recall that confidence intervals are generated always by taking an estimate plus or minus a crit value times the standard error of that estimate or of that statistic. Stat, estimate, interchangeable here. So in this case, our estimate, we're talking about the difference in population proportion. So this is what we're trying to estimate. Our estimate is this, the difference in my sample proportions. The crit value, because it's a z normal curve, is going to be a z crit. And the standard error of the statistic is going to be that standard deviation formula. Boom. Just plugging in your hats. Your sample you don't have the true proportions, so you plug in the sample proportions. Okay? So estimate, critical value, standard error of that estimate. Okay? All right, that's it. Distracted shooters. You make 18 out of 26 free throws when shooting with distraction, and you make 22 out of 26 shots when you're shooting without distraction. Why can't you analyze the difference in the true proportions of shots you made with and without distraction using a two-sample z interval for the difference in proportions? So we haven't really talked about how to do it yet, but this question is saying, why can't you do it? Which is a little strange, I guess. But basically what they're saying is one of the conditions perhaps fails, and that's why you can't do it. So if they made 18 out of 26, and it looks like they missed 8. That is not bigger than 10. So this is going to fail large counts. I can't even spell counts, my bad. So I don't, we don't really need to label it, but N1, P1, that would be 18. That's okay. N1, Q1, Q hat 1, that would be the 8, which is less than 10. So this is good. This one fails. The other one would be 22 out of 26. So again, one of them is going to make, and the other one is going to be 4. So it just fails large counts. Why can't you analyze the difference? Large counts fails. So a normal model is not appropriate. Okay. Now, if you're wondering what you would do in that case, you would run a simulation. That's whatever, right? Example voting. We want to estimate the difference in the population of voters that favor Joe Biden versus Barry Sanders. We take a sample of 100 people and record the sample proportion that favor Biden and the sample proportion that favor Sanders. Why can't we construct a two-sample z interval for the difference in proportions? What procedure is appropriate? Well, first of all, we're not going to conduct a two-sample because we don't have two samples. We have only one sample. So a two-sample is not appropriate here. But it kind of sounds like it might be appropriate because you're looking at a proportion that favor Biden versus a proportion that favor Sanders. But so let's just say the proportion that favored Biden, let's say the sample proportion that favored Biden is out of 100 people, let's say it's, 60 people out of 100. Once you know that, you know the sample proportion that favor Bernie Sanders, Joe Biden. If 60 out of 100 favor Joe Biden, then the rest of them favor Sanders, right? Assuming those are the only two options. These are not independent. These are dependent proportions, so you really shouldn't use this. What procedure is appropriate? At one sample, z-test for p. We should be comparing we should be saying the proportion that favored Joe Biden is equal to 50% against the alternate that the percentage that favored Joe Biden is maybe greater than or not equal to 50%, whatever you want to show. That's the type of test we should be running. It's just a one sample test. Okay? All right. So these examples, the notes are already filled out to kind of just save time. So let's just go over it. Presidential approval. Many news organizations conduct polls asking adults in the U.S. if they approve of the job the president is doing. How did President Obama's approval rating change from 2012 to 2013? According to a Gallup poll, 1,500 people in 2012, 52% said they approved of his rating or of his job performance, whereas 1,500 people in 2013, only 46 approved of his rating. So I can see that it looks like his approval rating went down. It certainly went down in the sample proportions. But I don't care about the sample proportions. I want to know, is this evidence that maybe the true population proportions showed a decrease? So that's a more difficult question to answer. Because of sampling variability. Calculate the standard error of the sampling distribution of the difference in sample proportions 2013 minus 2012. Interpret this value. So what is the standard error of p hat, let's call it p hat 13 minus p hat 12. Formula is square root. Instead of, I'm using this formula here again, right here it is, putting in the p hats. So that's going to be in 2013, that was 46%, times the complement, which would be 54% over 1,500 people, plus 52% times 48% for 2012 over 1,500 people. Type this in your calculator, you'll get this value here, 0.0182, also known as 1.8%. And again, how do we interpret that value? It's an important value in statistics. When we estimate, I'm saying this again and again, sorry, when we estimate the difference in our sample proportions, these estimates will typically be 1.8 percentage points away from the true difference in the sample. Sorry, I misspoke. Well, from the true difference in the proportions, not sample proportions. Our sample estimates will typically be this far away from the true difference in proportions. So if we were to take many random samples of 1,500 people in 2012 and 2013, the difference in the sample proportions who approve of Obama will typically be 1.8 percentage points away from the true difference in the proportions that favor Obama. Okay, that's a tough interpretation to get through, but if you can get through it, you certainly understand what you're doing. Use the results of these polls to conduct and interpret a 90% confidence interval. All right, so I'm defining my parameters. P12 is the true population proportion of all adults in the U.S. in 2012 that approve of Obama. P13, ditto 2013. And it is okay to do these little ditto things on the AP test. Just do one of them properly. Assumptions and conditions. Both samples were randomly selected. You gotta, make a little phrase here. Make sure you're addressing both samples. 10% condition. N equals 1,500 is less than 10% of all U.S. adults in both 2012 and 2013. We're checking two things here, kind of. Large counts, I got to check 4 combinations. 1,500 times 52%, 1,500 times 48%, 1,500 times 46, 1,500 times 54. Those are all bigger than 10. This is now optional. I will not require this. But because this checks out, then the sampling distribution of the difference in my sample proportions is going to be approximately normal. It means we can run the test. And the fourth check, don't forget this, 2 sample tests have an extra check. The samples are independent. Name the test. This is a 2 sample Z interval for the difference in proportions. Give the interval, -9% to -3%. Now I didn't show my work, and you don't need to here, but just to show you what I'm doing here, I did in the calculator, menu, statistics. This is a confidence interval for proportions. So 2 proportion Z interval. Successes. Well, that's going to be, I'm doing 13 first, so 13 minus 12. 13 minus 12. So I got to put in the 46% of 1,500. 0.46 times 1500. I hope that's an integer. I think it will be, so I think we're going to be okay. And this was 52% times 1500. Out of 1500, 99%, 90%. And it calculates it for us, or negative 3% to negative 9%. Negative 3% to negative 9%. So what that means is, because we're going P13 minus P12, that means P12 could be 3 percentage points bigger than 13, or P12 could be up to 9 percentage points bigger than P13. So it looks like there is a difference here, because 0 is not in the interval. Interpretation, we are 90% confident that the interval from negative 9% to negative 3% captures the difference. Make sure you state where you did your differences in the true population proportion of U.S. adults that approved of Obama in 2013 and 2012. So that's the entire procedure for a confidence interval. Okay? All right. Should we stop the video here? Yeah, let's stop the video here.